Good morning, students. This is going to be a video to show you how to draw a motion map or dot diagram of linear motion from a position time graph. So on the left I have a position time graph. Notice it is a horizontal position time graph because x is in meters, that's a position, and x always represents a horizontal position. The time was modeled from 0 to 600 seconds. So first thing we typically do is we draw an axis to represent the motion that we're modeling. This motion starts at 0 meters, so I can start my axis numbered over here at 0 meters. And I can indicate that to the right is a positive direction. That's typical. Now, the object moved from 0 to 300, so I can, on the right here, make a maximum distance of 300 meters. It's not always necessary to number this axis, but it does sometimes make things easier. And that would make this position 100 meters and this position 200 meters. I'm not trying to get these exactly perfectly evenly spaced, not being that careful, but it should look about right. Now, the next thing to do is to draw dots representing the instantaneous position of the object at certain times. Since I have 600 seconds modeled by the graph, I have to use a non-standard time interval. Typically, if I draw two dots like that, and I number one t equals 0 seconds, I usually mean that one to mean 1 second later. Sometimes it's a tenth of a second. But for this one, let's say that this equals t equals 50 seconds. So two dots are indicating a time interval of delta t equals 50 seconds. That'll allow me to get all the 600 seconds on the graph. So the object starts at 0, 0. Here, I'm going to move that up a little bit. I usually like to indicate the first dot by saying t equals 0. And then at 50 seconds here, the object is at 50 meters. At 100 seconds, the object is at 100 meters. So I can draw the dots that show that. And then it just continues at a constant velocity till we get to 300 meters. Now let's check that. Let's see. 0, 50 seconds, 100 seconds, 150 seconds, 200 seconds, 250 seconds. So I'm going to number this one, t equals 300 seconds, just to keep track for myself. Now I'm up here on the graph. The object stays put for 100 seconds till 400 seconds. Since I only drew a horizontal axis here, the vertical on the page doesn't really show motion. If I wanted to indicate that, I draw a positive y-axis. So I didn't do that, so I'm just going to stack my dots here. And that is indicating that the object stayed put at 300 meters until t equals 400 seconds. And now the object turns around and goes in the other direction, in the negative direction, towards 0. And at 500 seconds, the object is at 150 meters. So that would be here. And that is a whole 100 seconds from where I was. Oops, I didn't number that correctly. Let me fix that. Whole 100 seconds from where I was, so I'll go halfway between the two. And put a dot here. And then, let's see, I'm here, t equals 500, and then at 600 seconds I get back here. So I'll put another dot here in the middle. Okay, last step is that we typically draw velocity vectors and sometimes acceleration vectors on the dots to show, to give a better representation of the instantaneous velocity of the object. This line has a slope from the beginning, so I'm going to go ahead and put a velocity vector at t equals 0. There are two styles. Some people draw the vectors halfway the distance between the dots, approximately, and other people draw the vectors all the way to the next dot. I tend to draw them halfway. Okay, so these have to be longer. Notice I'm not being super careful here, so I'm going to show you what we do when that's the case. Now, we don't know what happened at 0 meters, but the line has a slope at that point. There's no indication that the object stopped, so I'm going to go ahead and draw a velocity vector on my last dot. It's a little ambiguous, so you could get away with not drawing that, or if you knew more information, you could do something else there. Now, the last thing I'm going to do is, as I said, I wasn't very careful with the arrows, and I usually put a little tick mark, hashtag, hash mark on each one of these to indicate that they are the same value, and then I'll put 2 here to indicate that these are all the same value, but that they are greater than the ones with 1 mark on them. 2 doesn't necessarily mean twice as much, but it could in some cases. I didn't indicate that. And the last thing I'll do is I'll put t equals 600 seconds. See, I guess 2 marks in this case does indicate twice as fast, but I wouldn't count on that. It's okay to put 2 marks and 1 mark when one is just bigger than the other. I'm stopping for a second to look at my work and make sure everything makes sense. This is 500 seconds. This dot looks fine to me, so I'm going to say this one is finished. So that's how to do a motion map from a position time graph for one-dimensional motion of constant velocity. We'll look at constant acceleration a little later. The other representations that you might be asked to do, sorry, I made my screen go away, will be a velocity time graph and a written description of the motion in words. So I hope to get those done, a video done on those later.